So during this session on static inventory problem under risk, uh, we'll we'll again discuss other issues or the formulation part of say formulation and the solution aspect of the type 1 problem. So the formulation in detail we'll discuss, we'll provide the formulation, and we'll also talk about the so-called benefit analysis. This is very, very important in fact. In fact, there are two kinds of analysis we do. First one is either you go for benefit analysis, or you also may opt for the cost analysis. Okay, so during this session I will again I will continue my say discussions on type 1 problem, okay, followed by the benefit analysis. Now, in the last session I mentioned about the payoff or outcome matrix. Mainly we have used the term the payoff or the outcome. Okay, so against a particular order quantity and a demand level. Is it okay? So you need to determine the payoff or the outcome. So when you consider all the possible demand levels, suppose here is a case where say the demand levels are possible from 0 to n. That means the demand could be 0 units, or 0 could be 1 unit. The demand could be the jth units, or the demand could be n units. So this is your demand, and against this demand obviously the corresponding probabilities are known. Static inventory problem under risk. Now the order strategies, obviously there could be n number of order strategies. That means I am using these notations Q1, Q2, general notation is Qi, and then you have the Qn. So you form this matrix. So these matrix of possible order strategies and demand levels in respect of the given inventory item. That means is a single item case we are considering. So what you try to do, like say in general, suppose order quantity is Qi and say the demand level is Mj. So you need to the specify, you use these notations. That means f of Qi Mj. That means with this combination what is your payoff or outcome. Is it okay? In monetary terms usually you need to determine first. That means with all possible sales you first determine f Qi Mj. Is it okay? So I varies from 1 to n, and j varies also from I varies from 0 to n, and j varies from say 0 to n. Okay. Like now we are considering variable demand and constant lead time case. This is a very the standard problem. There could be few variations of this problem, but later on we will discuss those variations. Now the expected value of a demand strategy Qi, okay, is given by obviously expected value, okay, or expected payoff with order quantity Qi. So obviously this is the probability that the demand will be M0, and then what is the expected payoff with the combination Qi Mo. Okay. Next possibility is that the demand could be M1, corresponding probability is PM1, and then with the combination Qi M1, what is the expected, what is the payoff. Is it okay, that combination. So these exercise will continue. Ultimately you need to consider the probability of say the demand of n items, okay, n, and corresponding say the the payoff. So you have this summation j equals to 0 to n p mj f Qi mj. Is it okay? So I hope that you have clearly understood the notations, and and their interpretations. Now, where we have mentioned that FQIMJ, that means payoff, as I have already mentioned, payoff or outcome for order QI and demand MJ. Okay. This is your starting equation. The expression for FQIMJ, that means the payoff or the outcome, depends on the relationship between QI and MJ. It's clear, QI and MJ. That means either the QI is greater than MJ or the QI is less than MJ. It's possibility, and one case is QI equals to MJ. Is it okay? That is the best possible case. There may be two kinds of relationships. QI, that means order quantity, is greater than the demand. Overstock condition, obviously. So, you just note it down that in any inventory problem, say you need to deal with either overstock or understock. So, in majority of the cases, both overstock as well as the understock, both are considered to be very, very critical. So, first you consider the overstock condition, but supposing QI is less than or equals to MJ, that means order quantity is less than the demand. Obviously, you are unable to fulfill certain demand, and so it is an understock condition. Okay, so overstock condition is excess, and understock condition means you have insufficient stock to meet the demand. It's clear? If A, now what we will do, we will the several cost elements you need to consider, right? And say the several cost related say the elements you need to consider, as well as you need to consider the profit or also the benefit. So, these estimates you must have. So, now you have several notations. If capital A is equals to stock out cost per unit, so these estimates you have. Later on I will tell you what is the procedure you might follow to estimate the stock out cost per unit. Right now we are assuming that the stock out cost which we have estimated is a reliable one, and it is accepted one, and it is so the estimate is acceptable. Okay. B is unit profit or benefit. Okay, unit profit or benefit. L equals to loss from disposal of an overstock unit. So, overstock unit, what do you try to do? That means if it is overstock unit, what you try to do? You try to dispose it off. That means with a lesser price. That means obviously this is a salvage value. So, what we are assuming that suppose your original price is 10 rupees. Now, when you dispose it off, that means with a lesser price, that means you just you just dispose or say you sell it or salvage it with ₹2 per unit. So, the per unit there is a loss, 10 minus 2, that means the 8 units or 8 rupees you are losing from disposal of an overstock unit. So, that we are considering. P is unit cost, and payoff or outcome is expressed in profit or benefit terms. Is it okay? So, I have already mentioned that the payoff can be made either in terms of cost or in terms of profit or contribution to profit. So, here in this case, suppose so what will be the equation for the payoff under overstock condition? So, FQIMJ obviously is overstock condition. That means under whatever conditions, whatever with the demand, that means MJ, only that demand level or that demand also you can sell. So, the per unit selling you get say the profit of B. So, capital B into MJ minus this you are unable to sell, that means QI minus MJ, that is the overstock. Is it okay? Because QI is greater than MJ. So, QI minus MJ overstock amount, and for each one you are losing an amount of L. Is it okay? That means the original price minus the salvage price. Is it okay? So that is basically the L that you are losing per unit of overstock. So when Qi is greater than Mj. It's clear? In the next case, you may also face the understock condition. So understock condition, the outcome is that Qi into B. That means understock conditions and the demand is more, you have procured less. So obviously Qi units also only you can sell, and for each selling you get a profit of B. So it is Qi into B minus Mj minus Qa. That means this is the actual demand. You are unable to fulfill the entire demand. So obviously Mj minus Qi. So that is the understock. So this is the understock amount, and against each unit of understock you are incurring a cost of capital A. So the estimate of A is reliable, and it is a good estimate that we are assuming. So it is Qi into B minus Mj minus Qi into A, where Qi is less than equals to Mj. Is it okay? So this is both the conditions. That means it is overstock as well as the understock conditions we have considered, and it is essentially, we say that there is a possibility of selling. That means the item is item you are procuring, and item also you are selling. Is it okay? So obviously whenever there is the inflow of cash or inflow of money, so you try to calculate the benefit. Whereas when all the activities you carry out within your manufacturing setup, within your the organization, and so within your production unit, so obviously there is no question of getting the sales. So what you need to do, that means you need to formulate the problem in terms of the cost elements only. So the cost is also known as the sacrifice. Okay, is the cost or sacrifice term when payoff or outcome is expressed in cost or sacrifice terms. That means you are dealing with the production related to the production. So the first one is when Qi, that means the order quantity is greater than Mj. Now this order quantity you have already produced. In fact, it is the production quantity. Qi is the production quantity. So this production quantity is greater than the demand. So obviously, this is a production cost per unit. Already you have produced. So Qi into P is the cost. Is it okay? So Qi F Qi Mj equals to Qi into P when Qi is greater than Mj. But if suppose there is underproduction, that means there is a shortage, and the shortage cost per unit is capital A. So what is that shortage? Shortage is Mj minus Qi. Your requirement is Mj, you have produced Qi. So obviously the per unit you are incurring a shortage cost of A, right? So it is Mj minus Qi into A plus Qi into P, because already you have produced Qi units, and against each unit you produce, you incur a production cost of P. So this is the expression for F Qi Mj when Qi is less than equals to Mj. Okay, underproduction and overproduction, both the cases we have considered. When the basics of the problem formulation as outlined is known, okay, actually the basis of the problem formulation as outlined is known, we may opt for either benefit analysis when sales and profit of the item are considered, and outside supply case. Okay, at this point I have already mentioned, or you may opt for cost analysis when cost related data for the item are considered, and inside supply case. As we have been repeatedly mentioning that in any inventory control problem, either it is a outside supply case or an inside supply case. If it is an outside supply case, you go for benefit analysis. If it is an inside supply case, you go for cost analysis. Both these analyses are explained assuming the demand is a continuous variable. Okay. So now, if you go for benefit analysis, what do? What is the objective of benefit analysis? Determine order quantity Q such that expected profit, notation is EP, for the period is maximized. Okay. So this is here the main objective of the benefit analysis. And here just one time you determine the order quantity, because you are dealing with a problem called static inventory problem under risk. Okay. Now, expected profit, how do you get the expression for the expected profit? So expected profit is essentially expected revenue minus expected cost. Okay. Where ER is expected revenue, right? Now, in a given situation, what do you mean by the expected revenue? Expected revenue means expected sales revenue. That means out of the sales you are getting the revenue, and out of the salvage of say the excess quantity, you are also getting salvage revenue. So expected sales revenue plus expected salvage revenue when there is a possibility of salvage. Now, these are the the notations we have used, like say P1 is unit selling price, C is the ordering cost per order. Is it okay? Now later on we'll tell you that how can you estimate the ordering cost per order. That means essentially when you place an order, there are many kinds of activities you carry out. It is the responsibility of the purchasing department usually, and so you carry out lots of activities, and so before is purchase order is placed, and after and when the order is executed, that means the time between placement of an order and receipt of the supply. So before you receive the supply, you place the order. There are many types of activities you carry out, and any activity you carry out, there is a cost associated with it. So you need to identify those activities in a given situation, and you need to estimate corresponding costs, and in a systematic manner you get an estimate of the ordering cost, and usually ordering cost is calculated per order basis. One order may consist of say one item, or it could be more than one item. So both the cases later on we will discuss in detail. So the C is the ordering cost per order, V is the unit salvage value. Is it okay? So how to determine the salvage value later on when you go for excess stock modeling. So we will refer to this, that what is the how do you determine the best possible salvage value in a given situation under conditions. So V is the unit salvage value, Fm is the probability density function of demand M, that means it is a continuous random variable. Capital A is the stock out cost per unit. So again the stock out cost is estimated, and it's an acceptable good estimate, okay, that we are assuming. So when you go for benefit analysis, so this is the expected revenue. So how do you express expected revenue? So expected revenue is essentially the Q is the the order quantity Q. So the P1 into Q, that is the sales you can do. Now it may so happen that the M, that means the demand, may be less than Q. So obviously there is a possibility that the entire amount which you have produced or you are unable to sell it. So that's why we have said that what is this probability, the expected number of units remaining unsold. Obviously Q minus M Fm when M varies from 0 to Q. That means this is the expected number of units remaining unsold. Is it okay? So that's why Q minus this expression. Is it okay? And P1 is the sales price, unit sales price. Now plus there will be unsold amount, and the unsold amount, that is Q minus M Fm dm, and the demand varies from 0 to Q is the conditions. So when the M varies from 0 to Q, under this condition only there is a possibility of excess stock. Now what do you do? This excess stock, the certain recovery is possible. That means excess stock you can sell with the salvage price. So the salvage price per unit is V. So that's why it's V into the integration 0 to Q, Q minus M into Fm dm. That is the expected number of unit salvaged. So this is the simplified expression. So P1Q plus V into P1 0 to Q, Q minus M Fm dm. Expected cost is expected cost equals to expected purchase cost, ordering cost, and expected stock out cost. There are three elements in this. So what is the purchase cost? That means Q the units you have purchased, and for each one the purchase cost is P. C is the ordering cost. Already we have estimated ordering cost per order. One order you have placed because it is a static inventory problem under risk, and this is the shortage one. That means if suppose the demand is more than the order quantity, that means M minus Q. So and the M varies from Q to infinity, any value of M is a continuous case. So M minus Q into Fm dm into this is the expected number of units short, and this is the shortage cost per unit. So that's why it is multiplied with capital A. So now what is the expected profit? Expected profit equals to this minus this. That means expected revenue minus expected cost. Is it okay? So this is the expected revenue and this is the expected cost. So expected revenue minus expected cost is expected profit. So ultimately you get these expressions. Okay. For maximizing expected profit, EP, assuming it is a continuous function, and that's why it is differentiable, the first derivative with respect to the decision variable Q, your decision variable is the order quantity, is set at 0. Is it okay? So first derivative is set at 0. That means the partial derivative del Q of EP is equals to 0. This is the necessary condition, right? So first you satisfy the necessary condition. So you follow the steps, and ultimately what you get these expressions, the probability that M is greater than Q. What is the M? M is the demand level, is greater than Q, is equals to P minus V divided by P1 plus A minus V. So you just follow the steps. I am sure that you will understand each and every step. All these the details I have provided. So this is P minus V divided by P1 plus A minus V, and with some the manipulation, this is changed to with this particular ratio, that is ML, marginal loss divided by marginal profit plus marginal plus A. So this is referred to as probability that M greater than Q. This is basically the stock out probability, and this is the optimum stock out probability. Is it okay? Because you are maximizing, this condition is fulfilled. maximizations of expected profit. So, we have derived the expressions for the optimal stock out probability. Okay. So, this is marginal loss, that means divided by marginal profit plus marginal loss plus A. Okay. So, what is where marginal loss is equals to P minus V. What is P? P is basically the production cost. What is V? That is the salvage one. Is it okay? So, the P minus V is a marginal loss. You just make a note. Okay. And what is marginal price? That means this is the sales price minus the production cost. That is called marginal profit. Is it okay? Sufficient condition for maximization. Obviously, I presume that you know it. That means the sufficient condition is the second derivative, partial derivative with respect to Q of EP is equals to must be negative. Is it okay? Now, here is one, before I conclude this session, I will be referring to just one numerical example. Okay? A merchant wishes to stock Christmas trees. As I have already mentioned that many a time this static inventory problem under risk is referred to as the Christmas tree problem. Okay? Or say newsboy problem. So, here we are referring to the Christmas trees, and the Christmas trees are sold exclusively for a specific time period, say 1 week or 2 weeks in the month of December each year. So, a merchant wishes to stock Christmas trees for sale during the Christmas season. There is only enough time for a single order, right? Each tree costs $2 and sells for $6, right? Ordering costs are negligible. We are assuming that the C is absent, ordering cost is absent, and unsold trees can be sold for $1 as firewood. Is it okay? So, that is the salvage price essentially. V. The merchant must order trees in multiples of 10, and the demand distribution during the season in given in table. That means while you place this numerical example, that means you have collected the data, you have analyzed the data, and so the demand distribution in empirical form is in empirical form, and that is presented in the table. Now, the question is how many trees should the merchant order? That means what is the ordering quantity. So, this is the demand level. So, multiple of 10, that means demand could be 10, 20, 30, 40, 50 and 60. These are possibles. That means what we are assuming, and these are the possible probabilities. So, add them 1. That means what we are assuming, that there is no possibility of demand less than 10, and there is also no possibility of demand greater than 60. That means this is means all possible demand levels. That means it is an exhaustive situation. That is mainly, it may not happen in almost all cases. There is a theoretical possibilities, but here for the illustration purpose we are assuming that all possible demand levels are known. Okay, and the corresponding the probabilities are also known. So, what you try to do, that means now a payoff matrix is developed with the profit from each strategy and state of nature. Is it okay? So, the payoff, so the matrix you have to create. The expected value of each strategy is obtained by multiplying its probabilities of occurrence by the values of its outcomes and summing the products. Okay, all the individual the product terms you add. So, against a particular row you get the corresponding the expected value. Okay. So, in this case it is a sell situation. So, the expected value, that means in the payoff, that means in terms of the profit you get the expected say the payoff. The final selection is based on the strategy with the highest expected value. I have already pointed out. The best strategy is to order 50 trees with the expected value of 127.50. So, this is the table we have created. So, just you look at this table and how it is constructed. These values are given. These values are given. So 0.10 probability that demand is 10. 0.10 is the probability that demand is 20, like this. So then 10, 20, 30, 40, 50 and 60. So the order strategies obviously will be from 10 to 60. So 6 possible ordering strategies, as there are 6 possible demand levels. Now when you have, say, order quantity 10 and your demand is also 10, so how much you will be getting? That means 6 you are selling and your ordering cost is around 2. So the purchase cost is 2. So for each unit you are getting a savings of 4, the profit. So it is 40. Is it okay? So 60 minus 20, that is 40. And here also you could sell all the 10 units. So your return is 40, 40, 40, 40, 40. So you just look into the calculations that how do you get, what is the assumptions under which you get these values at 40, 40, 40 irrespective of, that means it remains at 40. The next one is the 20. That means here, that means 10 unit shortage. That means what you do? That means there will be excess of 10 if the demand is 10. So these 10 units you can sell as firewood and with a price of so the 1. So that's why it is 40 minus 10, that means it becomes 30. This is 80 straight, and for all other demand levels it remains at 80 when the order quantity is 20. So like this you calculate, is it okay, for all demand levels, okay, what is the payoff against a particular order quantity. So this the matrix is created. Next what you do, against each ordering strategy you calculate the expected value. So how do you calculate the expected value? Like for example, for the order strategy 10, this will be 40 into 0.1 plus 40 into 0.1 plus 40 into 0.2 plus 40 into 0.35, like this, it will be 40. For the second one, whose ordering strategy is 20, it will be 30 into 0.1 plus 80 into 0.1 plus 80 into 0.2, like this. So you add all these values, individual product terms, and you get 75. So like this you complete, you do the calculations for all the rows and you select that row, that means which gives you the maximum expected value. So in this case, when the order quantity is 50, you get a return of 127.50 as the maximum. So that's why you select an order quantity of 5. Okay, so this is a simple exercise we have carried out. Later on, we extend these exercise in some other details in different forms under different conditions. Okay, so I conclude this session. Thank you.